DeepSeek V4 is an AI model that's almost at the frontier on benchmarks. It goes head-to-head with Claude Opus and GPT 5.4. There's a smaller model called Flash that's not far behind. It can code, reason, manage 1 million tokens of context, and it costs next to nothing to use. You can also run the whole thing on a laptop fully offline. I'll go over it step by step. Just a quick background. DeepSeek is the Chinese lab that made R1 last year. They just dropped V4 two versions, Pro and Flash. The big Pro for data centers and the smaller Flash. Flash is the one that really matters here. Start with the cost, since it's the part anyone can use right now via the DeepSeek API. Flash costs 14 cents per million input tokens and 28 cents per million output. Claude Opus, for comparison, costs $5 per million input and 25 per million output. Opus's output costs nearly 90 times more than GPT 4.4, while Opus Flash is cheaper than Google's budget model and Anthropic's budget model. It's the most affordable, capable model available. What that looks like in real life. People on Reddit say they spent 5 cents on 4 hours of heavy coding with subagents. In loops, someone used Flash for everything for a week. And for less than $1 a month with a Claude Code subscription, you get access to Anthropic's coding tool, whereas the top tier is $200 ATES. Month. You could use Flash nonstop all day, every day, and your monthly bill might still only be $10. But there's more to it than just the price, since you don't control the AP. And just this week, Anthropic announced it's putting third-party agent. Usage behind a separate credit meter means subscribers who've been using Claude with coding tools now have a new limit. Some companies have already burned through their whole year's AI budget. OpenAI can reject your requests if their filters block something. You're renting intelligence on someone else's terms. They switch the rules, you adapt, and that leads to another thing Flash lets you do. Run it locally. Get the hardware once, no subscriptions, no per token billing, and no one deciding what requests are allowed. Your data remains on your machine for businesses, meaning health data, proprietary code. Anything that has privacy requirements, none of it ever leaves your control. And if you're running AI agents, assistants working for you in the background, checking things, writing code, using a local model means it can run 24/7 without you checking the meter because you own the capability. It's affordable and you can get it. But is it actually any good? DeepWeek's own benchmarks show Flash close to Pro on reasoning. And Pro trading blows with Claude Opus 4.6 and GPT 5.4. And Gemini 3.1 Pro scores in coding and math should be taken with a grain of salt. What counts more is what people actually using it are finding on the local Llama subreddit. A developer wired Flash into their coding agent and threw it at a large code base over 100 tall calls across. Several runs, editing files, running tests, navigating directories with no single error. Someone else A/B tested it against Claude and found the quality gap was barely there. There are more reports just like that. There are people who had a bad experience, and I'll get to those. So how does a model that hits this level of performance actually run on consumer hardware? 3 engineering tricks are stacked together, and they're what make a laptop even a word you can use here on paper. V4 Flash has 284 billion parameters. That sounds crazy for a personal machine because a dense model that size at standard precision needs well over 500 gigabytes of only memory for the weights on an AGPU server rack, not a laptop. First trick is the mixture of experts and moo. The concept isn't new, but DeepSeek has been refining their version for years. Picture a rolling mechanics cabinet with 1,000 drawers. That's a total of 284 billion parameters in knowledge. But when you go to fix something, you don't open every drawer or maybe just 2, like the socket wrench. And the hex key, the remaining 998 remain closed. That's how MOA functions for every token. The model only runs about 13 billion parameters worth of expert modules. The other 271 billion stay in memory if you need them, but they don't burn any compute. So per token, it functions like a 13 billion parameter model while pulling from a knowledge base 20 times bigger. DeepSeek's version uses hundreds of small experts rather than a few large ones, making it more granular than earlier MOE models, like Mixtravio. Some experts are shared and always on for basic language, while others are rooted and specialized. And they fix the load balancing problem without the typical quality hit that granularity. And balance is what keeps the active compute so low. Second trick, attention in a transformer means every token checks in with every other token. The issue is that it's a quadratic double context quadruple work with a million tokens, which means a trillion comparisons plus the KV cache. The model's short-term memory also expands with context, and at a million tokens, that cache would eat about 80 gigabytes of its. DeepSeek's fix uses hybrid attention with two modes. The first one compresses every 4 tokens into a single summary entry, so a little scanner grabs just the most relevant ones to give them full attention. Most of the context gets left out. The second mode is more aggressive, squeezing every 128 tokens into a single entry. A million tokens turns into roughly 8,000 entries, and 8,000 squared is a drop in the bucket. So you just run attention on all of them. Both modes keep an uncompressed sliding window of recent tokens. So recent context stays sharp net. Effect at a million tokens, the KV cache drops to about 7% of the previous generation instead of 80 gigabytes, maybe 5 to 10. So MIA cuts down the active compute and hybrid attention cuts down the memory, together giving you roughly a tenth of the compute, and less than 1/10 the memory of the previous gen at long context. But the model is still physically big. The download from DeepSeek is roughly 160 gigabytes. To load this into memory on a single machine, you need one more step for quantization. Think of it like rounding. Instead of keeping every number to 16 decimal places, you just round to 4. Or maybe 2 means you lose a bit of fidelity, but you save a ton of space. That's how you take a 160 gigabyte download and make it fit into a real computer's memory for DeepSeek. Training V4 in 4-bit precision from the start is unusual. Most models compress once training is done. They baked it in using standard 4-bit quantization, and V4 Flash requires a machine with 100 and 28 to 192 gigabytes of memory. That's a high-end Mac Studio for around $6,000. Not cheap, but you can order one and set it on your desk. People have pushed Salvatore Sanfilippo, who created Redis, the database that runs behind a huge chunk of the internet. Built a custom 2-bit quantized version that fits in about 70 gigabytes. That's within reach of a MacBook Pro, with a 128 gigs of RAM. His engine now works with NVIDIA and AMD GPUs as well. NVIDIA's DGITS workstation comes with 128 gigabytes of unified memory, consumer-adjacent hardware, where a 100-hour and 28 gigs is now becoming the norm. So the path is at 4-bit, a $6,000 max, Studio at 2-bit, a high-end MacBook Pro, or an NVIDIA Digits box, not impulse buys, but stuff you can grab at retail. That's how a model with 284 billion parameters ends up running on your desk completely offline. Now I want to be fair about what this really is. The real-world reports are a mix alongside the people getting great results. Some developers run into real issues because Flash doesn't always follow instructions as reliably as Claude, particularly on precision tasks. People are complaining about strange symbols messing with things they shouldn't. One user couldn't get it to follow basic formatting rules for a customer service chatbot, just refused the pattern. Flash is excellent when the task is narrow and well-defined, sloppy when instructions are open-ended or require sustained discipline. So it's not a drop-in replacement for Claude Opus just yet, but many people have settled on a workflow using Flash as a worker for well-defined implementation tasks. A smarter model for planning and review. In that role, Flash is insanely budget-friendly. You won't get much from just a single benchmark or price cut. It's the Just 6 months ago, running a state-of-the-art AI model locally was a fantasy, but now, a year and a half later, it's a reality. Was theoretically doable, but practically silly. Right now, there's a model you can grab, quantize, and run on a desk to code and reason, and handles context well enough that real developers are using it for real work. The gaps are real, But the gap between frontier and local just shrank a lot if that pattern holds next. This version narrows it down even more. We covered a few topics that could each be their own episode, like the open source AI landscape right now, Kim Maikwen, and GLM. So all these labs are racing, and why do the best models keep showing up for free, while frontier models cost so much? The token economics behind those prices, and if they can hold up, or how coding agents actually function under the hood. What happens if you give AI tools and let it run? If you want to do